Hello and welcome to Physics with Amol sir. This is the video for class 10. We are going to start with the chapter of light, reflection and refraction. Okay, so let's begin. So first question, what is light? Light we define as a form of energy which gives us the sensation of vision. Correct? It is not a new thing for us. We know what is light. Correct? Light is very important part. Because of light we are able to see things. In this chapter, we are going to focus on two very important properties of light. First is reflection and the other is refraction. Of course, reflection is something that we have learned right from 6th standard. Correct? So I am not going to go too deep into it, but let us still discuss what we mean by reflection. We'll define reflection as the bouncing of light when it is incident on a surface. So when light will fall on a surface, it will get bounced back. Correct? And that we call as reflection. What we mean by that? So, any material that you see around you, the reason that you are able to see that object is because it is reflecting the light. For example, you can look at the things around you. Correct? You look at your table, you look at your mobile phone, you look at your pen, pencil. Light from your room, light from the tube light or the sunlight, it is falling on that material and that material is reflecting the light. That reflected light comes to our eyes and then we are able to perceive that particular object. Correct? So that is what is meant by reflection. Thanks to reflection we are able to see the objects around us. Of course, the colors that we see of the objects is also due to reflection. We have already studied that light is made up of 7 colors. White light is made up of 7 colors. So let us say you are looking at an object that is red in color. So what happens is white light falls on that object. It absorbs all 6 colors and it reflects only the red color. So when it is reflecting the red color, that red color when it reaches your eyes, the particular object looks red to you. Correct? So that is meant by reflection. And it is a very important property. Reflection helps us to see the objects around us. Because of reflection, we need only one source of light. Okay? So even if you have one tube light in the room or one candle, okay, the entire room gets illuminated because light gets reflected by all the surfaces. Correct? Again, in 8th class, we have learnt about something called as regular reflection and diffuse reflection. A surface, for example, a mirror, a highly polished surface, it has regular reflection. If you stand in front of the mirror, you are able to see your image because it is reflecting all the light. But if you stand in front of your wall, you cannot see your image. But still remember, it is reflecting the light. A surface like a wall, it has a rough surface. So because it has a rough surface, the amount of light that is reflected, it is not as much as that of the mirror. Correct? When the rays of light are reflected by a wall, by a rough surfaces, the directions are all different. So we don't get an image formed. But still a surface like a wall is also doing reflection. Okay? So remember that about reflection. Now, let us learn about the law of reflection. A very simple law. What the law of reflection says, the angle of incidence is exactly equal to the angle of reflection. That is the basic law of reflection. So here you will see an incident ray that is reflected on a plane surface. Correct? So when the incident ray is coming on the plane surface, it gets reflected. And here we get the reflected ray. So where the incident ray is intersecting the plane surface, we have drawn a normal, that is a perpendicular. Correct? And you can see the angle that the incident ray is making with the normal, that we call as angle of incidence. And the angle that reflected ray will make with the normal, we call as angle of reflection. The law of reflection says angle of incidence is equal to angle of reflection. Remember, this rule follows every time. Whenever you will have reflection, you will have angle of incidence exactly equal to the angle of reflection. So it doesn't matter whether the surface is concave, convex, plane, rough, whatever kind of surface you will have, whenever a ray of light is incident, it is going to follow the law of reflection, where I will be equal to R. Okay? Now in this chapter, this is something that we have learned till 8th standard. In this chapter, we are going to learn about the reflection that is done by spherical surfaces. Okay? Or more specifically, spherical mirrors. So we define two types of spherical mirrors. One is called as concave mirror and the other is called as a convex mirror. So what we see in the diagram, we have a concave mirror and we have a convex mirror. To help you better understand it, let me show you this. So this is the ladle in my hand. So if you look at this ladle, correct, inside you can see this part which is going inside. So this is the reflective part, right? So this surface is the concave mirror part. Okay. On the other side, this part that you see, correct, which is actually bulging outside, that is the convex mirror. Okay. So if it is going inside, bulging inside, that is a concave mirror. The mirror which is bulging outside, that is a convex mirror. Okay, remember. So this is a concave part and this is the convex part. So in this particular chapter, we are going to learn about concave mirrors and convex mirrors, and we are going to learn about what kind of images and how the images are formed by these mirrors. To better understand that, let us see how we are going to construct the ray diagrams. So here is a concave mirror. Okay, the parallel line that you are seeing, the dotted line, that is called as the principal axis, and you will see that the principal axis meets the concave mirror at a point. That point we have marked as P. So this is called as pole of the mirror. Correct. Same thing we can make for the convex mirror as well. Here we are looking at a concave mirror. So where the principal axis meets the mirror, that point is called as the pole of the mirror. Now you can imagine that mirror to be made up of a larger sphere, right? So whatever is the center of that sphere, that is called as C, okay, or center of curvature, that you will see marked in the diagram. And next thing you will see, between P and C there is a point that is marked as F. Okay, this is called as the principal focus. So P is called as pole of the mirror, C is called as the center of curvature, and F is called as the principal focus. Okay, now we do some measurements over here. So if you measure the distance between C and P, that is between center of curvature and pole, that distance is called as radius of curvature. Okay, so distance between center of curvature and pole of the mirror is called as radius of curvature. Next, distance between the principal focus and the pole, that is called as the focal length. Okay, distance between principal focus and pole is called as the focal length. And what is to be remembered is the focal length is always half of the radius of curvature. Okay, so focal length we denote by small f and the radius of curvature we denote by capital R. So what we get is 2 times f is equal to R, or we can say f is equal to R by 2. Remember, this is applicable for concave mirrors as well as convex mirrors. Okay, so this is the diagram, and these kind of diagrams we are going to follow when we are going to do the ray diagrams. Now let us talk about the reflections that are done by concave mirrors. There are 3 important rules that we are going to follow when we are going to make the ray diagrams to understand image formation by concave mirrors as well as convex mirrors. In the diagram I will be showing it for concave mirrors, but remember the same rule applies for convex mirrors as well. First rule, if there is a ray that is coming parallel to the principal axis, it will get reflected. After reflection, it will pass from the principal focus. Okay, the first rule we'll follow is that the ray which is parallel to the principal axis, after reflection will pass from the focus. Okay. Second rule, if a ray is passing from the focus, okay, if the incident ray is passing from the focus, after reflection it will go parallel to the principal axis. Okay, so if a ray is going from the focus, it will get reflected, and after reflection it will pass from the it will pass parallel to the principal axis. Third rule, if a ray is incident and it is passing through the center of curvature, it will get reflected, and after reflection it will pass again from the center of curvature. Okay, so any ray that will pass through the center of curvature will get reflected along the same lines, okay, from the center of curvature. Next rule, if there is any ray which is incident directly on the focus, after reflection it will get reflected on the other side of the principal axis. For all these cases, remember, we are always following the law of reflection, where I is equal to R, angle of incidence is equal to angle of reflection. If you understand these rules, you can make the ray diagrams for any kind of image formation by concave mirrors. Okay, so I hope we understood these points. Next class, we are going to talk about image formation by concave mirrors and convex mirrors. Thank you.